Okay, subtract 3 and carry the 1, and that's the meaning of life. Oh, I didn't see you there. Welcome. I'm just doing some math and making a video and thought that I would share with you some information that you would like to know, or I'd like you to know about the topic from, well, actually, let's go to Khan Academy and figure this out. A little minimization of the window there, and hi right at the top. And I went into AP Calculus AB. I didn't assign it yet. You need to do that yourself. But it's in the I'm going to back out of this for just a second here. Do you ever wonder if this is his first take of the day? Anyway, 56% mastered on the concept, applications of integration, and way, way, way down near the bottom is the concept volumes of washer method. You're not ready for that. Volumes of cross sections of triangles and semicircles. So let's begin. Point of order, you may have saw that I had this window popped up already, but I haven't attempted any of these. So if I'm wrong, we'll be witnessing the cringiness of what is Mr. Lebrant being wrong. The base of a solid, capital S, is the region bounded by the parabola x squared equals 8 times y. So that's the parabola here. And the line y equals 4. Cross sections perpendicular to the y-axis are semicircles. Trying to get an idea. I think I might need to draw this one out. So let's just bring up Visualizer here, where I have the document camera, lovely arm, ready to do some work. Okay, so capturing what I see a perpendicular y-axis to the x-axis, a little bit of labelage there. There's a parabola shape, something like that, cut at the top. And so if I can imagine this thing kind of being like on an angle, that still looks like a piece of paper, but imagine it being on an angle. There are these half circle, like not quite like a dome, Quonset hut. Yeah, this is like a weird Quonset hut. You know, you're not sure what I'm talking about. I know you've seen these before. Quonset hut. That's not how to say it. Oh, it's that way. Quonset hut. It's looking something like this. It's made out of a semicircle, and this is a Quonset hut. Someone decided to take a silo, cut it in half, and lay it on the ground. Quonset hut. But the interesting thing with over here on Visualizer on the notes is that one end tapers down to a tiny little point. So less of Quonset hut and more like the this is on Colorado Cabin. My favorite show that I like to watch right now is Building Off the Grid. Yeah. As always, feel free to scroll. This was so dope. This episode was like, these people have that much money to spend on that? Ridiculous. You see it right there? We're making a structure kind of like that with this, I'm pointing at my screen, you can't see it, with this shape as the ground floor. Isn't that cool though? Building Off the Grid, Colorado Cabin. I don't know, people that have way more money than I ever have the chance to make in my life decided, yeah, that tent thing, put it on the hill. Okay, so kind of trying to draw it. These are all meant to be like, half circles. And it just kind of grows out, looks like a beetle. We want cross sections perpendicular to the y-axis that are semicircles. So when we look at this one, it's this distance right here that goes from the y-axis out, that's the radius. Remember, anything we do still has an element that goes back to volume is base, as in the base area, times height. It's just that the base area is a semicircle where you're looking at a cross section from, like the front. Like this is the floor. You're standing on the floor and you're seeing the circle go over and around you. So even though I'm drawing this flat, it's not meant to be flat. It's meant to be popping up out of the page. And so the area is this wall. Imagine like all of these walls that are in here, kind of like forming some sort of like rigid structure that this Colorado building off the grid cabin has its canvas draped over it, and we want to know what's the actual volume on the inside. So each of those panels that go vertically is this cross section, but they're circles. So because they're circles, the formula for this is still pi r squared, half circles. It's cut in two. And so it's popping out from the image. It's popping up off the page at us in the form of a circle. I'm also looking at this and noticing it says y equals 4. So we're writing the function in terms of a y value. And then we're also writing this other one, x squared equals 8y. I'm having a little bit of a trouble here because that function, this function right here, can be defined in terms of x if we square root both sides. So x equals plus or minus, although we'll only need the plus, and that might become evident in a little bit, square root of 8y. That should be the exact same picture as what we have here. X squared equals 8y, or x equals the positive half and the negative half of the square root of 8y. We could simplify that. I'm not going to bother with that. That's actually going to go away here in a second. This line right here, that's x. That's how far out to the side we go. So the radius, r, is x. And specifically, we don't need the negative version of it because you're going to square it anyway. So r will be squared. Check out my pointer. R will be squared, which makes this thing actually become 8y. So our volume formula, the base cross-sectional face of the volume formula is pi, I should write with a capital B here, times r squared, so square root of 8y squared. And then because it's a semicircle, not a full circle, we're going to divide by 2. So there it is, divide by 2. I'm using the y variable because we're going in a vertical direction. We're not going from side to side, which is an x integration problem. We're going vertically, so we're going to use the y as our input function. And that means we got to write all of our functions in terms of some x. I don't have to worry about y equals 4. That's just the upper limit of integration. Down here at the bottom, hopefully you can see my screen, down here at the bottom, you're going from 0 to 4. So our limits of integration, that's our height, if you will be from 0 to 4. And then this cross-sectional base, it depends on the y value. So I'm just going to write b delta y. I didn't want to rewrite all of the b thing right there. But I have the structure of the problem. Maybe I'll write it in the next step down because I do want to kind of like make my job a little easier. I'm going to have to go into some sort of technology component. Let's see. So the volume is this integral formula, which means it's the volume from 0 to 4 of pi over 2 times 8y dy. And I write it like that. I might need to use a calculator at all. Yes. Okay, so I write it like that because it's going to be the cross-sectional base area, semicircles, and we're going from 0 to 4, so there's my limits of integration, 0 to 4. I can do some simplifying with pi over 2 times 8. I mean, 8 over 2 is 4, and pop that out. So we really are talking about 4 pi times the integral from 0 to 4 of y dy. Integral of y, 1/2 y squared. So no more integral symbol needed. Now we're going to write 4 pi times 1/2 y squared from 0 to 4. No more integral because this 1/2 y squared is the antiderivative of y. So using that, we have 4 pi. Can I take the 1/2 out? I think I can take the 1/2 out. I can take this 1/2 and pop that out because it's just going to be multiplied in 2 layers. So I really have 2 pi times y squared from 0 to 4. Or I have 2 pi from 4 squared minus 2 pi times 0. Oh, that's easy. 0 squared. We like things. All right, a cable mishap. As always, that's a lovely image to freeze on. meme it, if you will. We're going from 0 to 4, so the 0 is a nice element to include. That cancels out. We're left with 2 pi times 16. 2 times 6, 32 pi. All right. If I'm right, plugging it in and signing out of this thing. 32. I almost was wrong. Assuming I'm still right. Determine the exact volume. I have to have the pi there. You cannot just go to Desmos and get a decimal and be done. If you do, side note, let's Desmos this. I guess this is my check before I actually check. You know, you want to get the green circle, not the gray one. Okay, so I've got a lot of elements here. I'm going to rigidly define b of y as pi over 2 times the square root of 8y. And that's going way back. I didn't do any simplifying there. We're just going to check to see if we are doing this right. The integral from 0 to 4, not you. Come on. To 4 of b y dy. They give me this 100. That's a decimal. So here's a way to trick it. You know that it's supposed to be an exact answer. So if I take that answer and I divide by pi, not right there though. Maybe like at the end, divide by pi. That's not a divide sign. 32. Okay, so I got to put the pi back in. The answer is 32 pi. Yes. Okay. Playful, chugging it. Oh, I didn't give the chime because I'm... Okay, anyway. Yep, we are correct. That's the way to do it. So I'm going to go ahead and do some behind the scenes as I answer the other 3. Hopefully get 3 in a row correct. But just remember, there's a couple of things to keep in mind. One is knowing your shape. Is that in frame? There we go. Knowing your shape when you're drawing the curve. It'd be helpful to have Desmos open, have a calculator ready to go beside you to get some calculations ready. We're still using our basic... Volume is base times height. Volume is the area of the base face. And when you understand what the shape of the base face is, this piece of cake, because that's your function. All right. Thanks for watching. Comment, like, subscribe, ring the bell, pound it, noggin. See ya. That's my hand.